Identifying and exploiting directory traversals. In this section, we will explore directory traversal attacks, also known as path traversal attacks. This type of attack can be used to access sensitive files on a web server and typically occurs when a web application is not sanitizing user input. For a web application to show a specific page, a web server provides the file from the file system. These files can be located in the web root directory or one of its subdirectories. While it's important to understand how to exploit directory traversal vulnerabilities, it's also crucial that we can identify them. We should always check for vulnerabilities by hovering over all buttons, checking all links, navigating to all accessible pages, and, if possible, examining the page's source code. Links can be an especially valuable source of information, providing parameters or other data about the application. For example, if we find the following link, we can extract vital information from it. First, login.php indicates that the web application uses PHP. We can use this information to develop assumptions about how the web application works, which is helpful for the exploitation phase. Second, the URL contains a language parameter with an HTML page as its value. In a situation like this, we should try to navigate to the file directly. If we can successfully open it, we can confirm that en.html is a file on the server, meaning we can use this parameter to try other file names. We should always examine parameters closely when they use files as a value. Third, the URL contains a directory called CMS. This is important information indicating that the web application is running in a subdirectory of the web root. Let's review a case study next. We'll begin by examining the Mountain Desserts web application. To access it, we'll need to update the etc hosts file on our Kali machine to use the DNS name. We will use this host name for both the current and following demonstrations. Next, let's browse to the target web application. The navigation bar displays a file named index.php, so we can conclude that the web application uses PHP. To gather more information about the page's structure, we should hover over all buttons and links, collecting information about parameters and the different pages we come across. At the bottom of the page, we'll find a link labeled Admin. We know the web application uses PHP and a parameter called page, so let's assume this parameter is used to display different pages. When we click on the link, we receive an error message stating the page is currently under maintenance. This is an important detail for us since it reveals that information is shown on the same page. In this case, we'll make a few assumptions about how the web application could be developed to behave in such a way. For example, when we open admin.php, we'll notice the same message that was shown after clicking the admin link. This message indicates the web application includes the content of this page via the page parameter and displays it under the admin link. We can now try to traverse directories in the potentially vulnerable parameter. We'll specify a relative path to etc password to test the page parameter for directory traversal. We're provided with the contents of etc password. We successfully leveraged the directory traversal vulnerability by using a relative path. In most cases, the web server is run in the context of a dedicated user. These users usually have limited access permissions on the system. However, users and administrators often intentionally set file access permissions to be very permissive or even world-readable. Sometimes this occurs due to time constraints in deployment or less mature security programs. This means we should always check for the existence of SSH keys and their access permissions. SSH keys are usually located in a folder under the home directory of a user. Fortunately for us, etc password also contains the home directory paths of all users. The output of etc password shows a user called offsec. Let's specify a relative path for the vulnerable page parameter to try and display the contents of the user's private key. We successfully retrieved the private key for the offsec user. Reviewing the output, we'll notice that its formatting is a bit messy. During web application assessments, we should understand that as soon as we've identified a possible vulnerability, such as with the page parameter in this case, we should not rely on a browser for testing. Browsers often try to parse or optimize elements for user-friendliness. When performing web application testing, we should mainly use tools such as burp, curl, or a programming language of our choice. Let's use curl to retrieve the SSH private key as we did with the browser. The SSH private key is formatted better using curl than in the browser. Let's copy the output and paste it into a file called dt-key in our home directory. Let's use the private key to connect to the target system via SSH on port 2222. We can use the -i parameter to specify the stolen private key file and -p to specify the port. Before we can use the private key, we'll need to modify the permissions of the dt-key file. If we don't, the SSH program will throw an error stating that the access permissions are too open.